Hi guys, welcome back to the channel. So today we are going to be solving today's street code question, which is longest ideal subsequence. So you are given a string s consisting of lowercase letter and an integer k. We call the t ideal if the following conditions are true. So t is a subsequence of particular string s, and then the absolute difference in the alphabet order of two adjacent elements in this t is less than or equal to k. And then we need to return this length of the longest ideal string. The subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of remaining characters. So let's say we are given this particular example where s equal to a c f g and then b and then d. So we need to pick subsequence from this particular string. So we are going to say the the string is going to be acf. This is one of the subsequence, and then let's say I take a f and then d. This is one of the subsequence. So we need to pick the longest subsequence where it satisfies two conditions. One is that it should be a subsequence, so that will be always true as we are taking subsequence of this particular string. And then it should, the two adjacent element which is present in this particular subsequence should have a difference less than or equal to 2. That means we'll consider a to 0 and then c to 2, like we'll be doing the map from like a to 0 and then b to 1 till z to 25. So this is going to be our iterations, like we are going to do the minus of this a so that we'll get 0 and then 1 till 25. And then we need to find these distances. Suppose let's say I'll calculate I'll take all the subsequence which are present in this particular string, and then I'm going to see whether this particular adjacent elements is lies in between these two. If it is lies in this k, then we can say that that string is ideal, but it should be longest. So we are going to take the maximum of all the lengths which are present in this particular ideal string. And then let's say I need to optimize this particular approach. Now what I'm going to do is I'm going to take each element which is present in this index, I'm going to use the previous answer which is going to be present. Suppose let's say I have 0, which represents the last index is a, and then I have 1, which means last index is b. So we'll have till 25, which is going to represent the z. Now I'll have all the lengths which will have a as the last index, and then this will be the longest ideal string which I can build till the previous index. Suppose if I take this, then at this particular point I'm going to see the length of 0, which is going to be 0 as of now, and then I'm going to pick maximum of 0 1 and then 1 plus the other elements. Like I'll take k equal to 0 and then k equal to 1 and then k equal to 2, and then I'm going to traverse all the cases and then I'm going to take the maximum of that. So for this it is going to be a of I, like it is going to have the length of I plus k, I plus some j, where j lies between 0 to k. And then after this we are going to take for each index and then we are going to calculate the answer. So for this approach, if we take the time complexity, it is going to be 26 into length of this particular string, and then the space complexity is going to be big of 1. Why? Because we are not taking any extra space, it is constant space. So let us see the code for this. So we are going to take length which is going to be of size 26, and then we are going to take next length which is going to be of size 26, and then we are going to take the current index and then answer. And then for each index we are going to take the current index. That means we are going to take out a from this s of I, so that we'll get the number from this s of I. 0 will be mapped, uh, a will be mapped to 0, and then b will be mapped to 0, and then z will be mapped to 25. So that we are going to pick with this particular current index, and then we are going to take j from 0 to k. So it can be difference from 0 to like it can have the difference of 0, or it can have the difference of 1 till k. So that's why we are going to take j from 0 to k, and then we are going to see whether this current index plus j lies in this range, that means 0 to 26. If it ranges, then we can pick this alphabet which is present. Suppose let's say i have I have current index as 25, and then j is some 3. Then if I add 25 plus 3, there will not be any alphabet which is like after z, uh, after z which is 3 places away. So that we are not going to get. That's why we'll take current index plus j should be less than 26, and then current index minus j should be greater than or equal to 0. And then for this case, we are going to take next length. Current index is going to be next length of current index, and then length of the current index plus j. And then for this we are going to take current index and then next length of current index plus 1 plus current index minus j. And then we are going to take the length as our next length, and then I'm going to maintain the maximum variable which is answer, and then I'm going to return answer. So the time complexity is going to be big of n, and then space complexity is going to be big of 1. Yeah, that's all for this video. Thanks for watching the video.